All right, so we continue with section R5 factoring, and we got through that factoring problem. We're on part 2, grouping. Sometimes the polynomial may be split into 2 parts. So we're going to look at how that can happen, and notice this will require that you have, just familiarity with these things, and then it becomes easy. Otherwise, it does not. All right, so let's try number 2 here, and how would we split this up? So in general, usually when we have 4 terms, we split it up 2 and 2. But this one doesn't work that way. This one splits up into 1 and 3. So I'm going to rewrite it this way. This is going to be 1 minus, and then this I'm going to factor out the negative, so it'll be x squared minus 2xy plus y squared. Okay, so that now this part is in the form a squared plus 2ab plus b squared. I'm sorry, minus 2ab plus b squared, and so it factors into a minus b squared. So this will be 1 minus, and this will be x minus y squared. Okay, and then now this is in the form a squared minus b squared. Your a is a 1 and your b is an x minus y. So you're going to factor it into a plus b times a minus b. Okay, so a would be 1 plus x minus y, and then 1 minus x minus y, and so I'm going to distribute the negative, so it would be 1 minus x plus y. All right, and if we were to distribute all that out, it would give us back 1 minus x squared plus 2xy minus y squared. All right, let's try number 3, and I'm going to leave number 1 to work in class, but number 3, maybe we'll just start off number 3. So number 3, it's a very long one, and generally these are very difficult to factor. So you want to look for maybe patterns that you recognize. What I recognize is that 2x squared plus 7x minus 15 is factorable. Yeah, it factors like that. So I'm gonna separate that into these 2, and then these 3 over here. All right. So I know that this is gonna be plus this 2x minus 3 times x plus 5. Okay, and this now, I'm just going to factor out a GCF, which is x to the third times 2x minus 3. Okay, so you'll notice the 2x minus 3 is in common, so if I factor that out, that leaves me with x to the third plus x plus 5. If I were to distribute this all out, I would get back that polynomial there. Okay. Notice that requires that you have familiarity with these and recognize. Okay, let's go on to part 3. Some other things that we want to point out about factoring. So when you're factoring negative or fractional exponents, like in these 2 examples, you want to factor out the GCF, including the variable with the least negative or least common fraction. Okay, so if we were to try this one, the least negative is x to the negative 2. So you would factor out x to the negative 2. I'm going to, I think you would want to factor out the 1/2 also. So you would factor out 1/2 x to the negative 2 power. I'm going to do this one. Okay, so on this one I would factor out x to the 2/3. So if I factor out x to the 2/3, by the way, factor out means that you're dividing it out. Yeah? So if I were to factor out, that would leave me 2 plus 5x. Okay? X is x to the first power, which would be 3/3. And if you were to multiply that back, it would give you the 3/3 plus 2/3 would be 5/3. And that would be your answer right there. Okay? And I'll leave the other one for you. And of course, we'll see it in class together. All right, so let's go on to section 5, R6, I'm sorry, that was R5. So R6, titled Rational Expressions. All right, so definitions, a rational expression is a ratio or fraction of two polynomials. And that means that you have a fraction with a polynomial on top, polynomial on bottom. Restricted values are values of the variable that make the denominator 0. So sometimes that might be possible, and so you would say x cannot be that number that would make the denominator 0. All right. Simplifying, so we have let a, b, and c and d be real valued expressions, then ac over bc is equal to a over b. That means that we have a factor on top and on bottom that's the same factor, we can cancel it. And of course, it really turns into just a 1. B cannot be 0 and c cannot be 0 because they're in the denominator. A over b times c over d is ac over bd, and that just tells us that you multiply straight across. And again, the restriction b cannot be 0 and d cannot be 0. That means the denominators cannot be 0. A over b divided by c over d is equal to a over b times d over c, which is the reciprocal of the second fraction. And that just tells us that when we do division of fractions, we multiply times the reciprocal of the second one. And again, with all the restrictions that the denominators cannot be 0. And then finally, letter D, a over b plus or minus c over b is equal to a plus c over b. And again, b cannot be 0. And that just tells us that we can add or subtract fractions if they have the same denominator, and we add or subtract just the numerators. All right, let's try some examples, see what we should be able to do with that. Let's start with example A number, which says simplify, state the restrictions on the variable. And we will do number 1, which is x squared plus 5x plus 4 over x squared plus 4x. So to simplify, we want to factor top and bottom and cancel factors that are the same. So I'm going to factor the top. The top is x plus 1 times x plus 4 over... and the bottom x squared plus 4x is x times x plus 4. Okay, so you see the x plus 4 is in common top and bottom. So we that reduces to a 1. So we have x plus 1 over x. Okay, and we can leave it like that. We can also do put each of the terms on top over x. So that would be 1 plus 1 over x. If we wanted to write it that way, I don't expect you to write it that way, but it's an alternate way of writing the answer. All right, let's go on to, and number 2 we'll leave for class. Number 2 is x squared minus 2x plus 1 over x minus x squared. Let's try part B, perform the indicated operation. So we have 3 examples. 1 is a multiplication, 2 is a division, and 3 is an addition. We will do number 1, and then we will start number 3. I'm not sure if I want to finish it here. I think I want to leave some of it for class. So, how do we multiply? Well, you multiply the top times the top, bottom times bottom. However, to be able to reduce, we don't want to do that multiplication. We actually want to factor everything first. So the first fraction is x squared plus 4x plus 4 over x squared minus 4. This is example 1. Times x to the third minus 8 over x squared plus 2x plus 4. Okay, so I'm going to factor first the first fraction, x squared plus 4x plus 4, that numerator, factors into x plus 2 squared. But I want to write out all the factors, so I'm going to write it as x plus 2 times x plus 2 over, and the denominator x squared minus 4 factors into x plus 2 times x minus 2, times x to the third minus 8 starts with x minus 2, and the other factor is going to be x squared plus 2x plus 4. Okay, and then the denominator x squared plus 2x plus 4, that one cannot be factored, so it'll stay x squared plus 2x plus 4. But I think you can recognize already that there's some common factors top and bottom, in particular that x squared plus 2x plus 4 that I just mentioned. So I'm going to put a slash on it to indicate that got reduced. In the first fraction, the x plus 2 over x plus 2, that got reduced. And then you have now factors x plus 2 times x minus 2 on top, and on the bottom x minus 2. And so the x minus 2's cancel, and you get x plus 2 on top over, and on the bottom you don't have any factors left, but there's a 1 there. So a 1, remember, because the factors can reduce down to a 1. So it's x plus 2 over 1, which is x plus 2. All right, that was number 1. And let's start off number 3. So number 3, we're adding, And so first we want to have a common denominator. To get a common denominator, you want to factor the denominators first. Let me read the problem. So it's the fraction x plus 4 over x minus x squared plus the fraction 2x plus 1 over x squared plus 4x minus 5. All right, let me factor the first denominator, x minus x squared, and I can factor out an x times x minus 1. And then the second denominator, x squared plus 4x minus 5, that's x minus 1 times x plus 5. Okay? All right. So your common denominator needs to have all the same factors. So you notice in your first denominator, you're missing the x plus 5. So you will multiply times x plus 5 on the first fraction. You can put that multiplication anywhere, because you're not going to do it for the denominator, you're going to do it for the numerator. So the first fraction had the numerator x plus 4, so we're going to multiply that numerator times x plus 5, and the denominator also got multiplied times x plus 5. We're just not going to carry out the multiplication in the denominator, only in the numerator. The second fraction is missing a factor of x, so we'll multiply both numerator and denominator by x. And notice when you multiply both by the same factor, you're just multiplying by 1, so you're not changing its meaning. All right, and so we have x plus 5 times x plus 4 for the first fraction, which will be x squared plus 9x plus 20 over the common denominator x times x minus 1 times x plus 5, plus your second fraction is 2x squared plus x over x times x minus 1 times x plus 5. All right, and I'm going to leave it there, and we'll finish that problem in class. Okay, so this will be the end of section R6.